be expressed in a curly braces. What I mean is this particular braces here is not something that you must use. You can create conditional statements without having the curly braces. So this is just an example of that. So if x is greater than 20, this is the condition here. And then this is what will happen if that condition is met. And this is what will happen if the condition is not met. So if x is greater than 20, we want to just take the power of the second power of x, that is the square of x. Well, if x is not greater than 20, okay, let's just take the fifth power of x. So this is just an example. So clearly x is greater than 20. So we are expecting x, which is 10, to be squared by 2. So if we do that, we'll see that the result is, okay, let me actually let me run that particular line again. So if x is greater than, and we can see that the result is 100,000. So the fifth power of 10 is 100 power, because x, which is 10, is not greater than 20. So that is why x 10 was not squared by 2. So I hope that is clear. Okay. So going further, this is just another way to check if a condition is true or false. So in this particular example, we are checking if the class of this particular hello world, if it's a character, this text, this hello world text, we are checking if it's a character. So if it's a character, we want this to be our output. That is, this is a character. But if it's not a character, that is, if the class of this text, this hello world text, is not a character, we want to just see not a character as the output. So normally, when you do something like this, I'm just running only this part, you see that the class is a character. So this condition is actually true when we check it with this particular string here. So we expect the result or the output to be this is a character, because the condition is met, and this is what executes if the condition is met. So let me quickly run that. So you see that the output is this is a character, because this particular condition is true. So notice how we did not have to put this particular part inside the curly braces. Like I said earlier, it is not usually necessary. When your code doesn't span beyond one line, it is not necessary. So only when you begin to have 2-3 lines and you want everything to be seen as one, that you need to partition it inside curly braces. But like this now, notice that this particular code is just one line. Yeah, it's just one line, one row. Doesn't go beyond that. So that is why mostly we need to use curly braces here. So the else statement is not mandatory. If the condition is not met and the else statement is missing, the program will not execute anything. So this is what I mean. Initially we had to indicate what will happen if the first condition, like if the condition is not met. In this case now, the else here prints no. So we do not have to, it's not mandatory to do that, to explicitly write this else no here. It is not. If the condition is not met, the else statement will not execute, nothing will happen. So I got rid of I omitted the else statement, and then let's try to see this particular statement. So if 2 is less than 1, print yes. We know that 2 is not less than 1. So in this particular case, the else statement, like the else instruction, should be run. But since we did not include any else instruction here, so nothing will happen. This code will just run and then no output. So let's actually do it. Okay, you see that it's returning just the code that we ran. No other, no result was printed, and that's because the first instruction was not, like, the condition was not true. 2 is less than 1, and then no else statement. So I hope that is clear. So the condition is not met, but since there is no else statement, the program doesn't execute anything. That has been confirmed. So the condition can be more complex using a Boolean expressions like and then or. So this particular symbol here is what we use to indicate or in R. I don't know if you are familiar with Excel, or is or, SQL, or is or, and the rest. But in R, we use this particular symbol here as the or. So I believe if you are in our last webinar, you'll see that we use this particular and or operators or symbols a lot. So we can also do the same in if and else, if statements and some other conditional statements like that. So in this case now, in this example, let me first assign x and y values. Okay. So now we are checking if we want to check if x is greater than 0 and if y is greater than 0. We'll see how these two conditions are combined using the AND operator. So if these two conditions, if they are met, then we want x to be added with y. So if these two conditions are true, but if they are not true, we want to just print stop. So that's just what this particular line of code is. So ensure that whenever you're using the AND operator, that the two conditions or the number of conditions that you are specifying must be met. Because if you want a situation where at least one of those conditions is met and then you get your out results, then AND operator is not the best to use. So AND is used when you want all your conditions to be true. So x greater than 0, let's run that, is true because x is 10 and 10 is clearly greater than 0. So y greater than 0 is true. Yeah, y is 7, so 7 is greater than 0. So you can see that both these two conditions are true. So it means that this whole parenthesis evaluates to true because the two conditions there that were combined with the AND operator are true. So the output now, when we run this code, the output, we expect this particular first instructions to execute, because the output is true. This else will not execute. Okay, so we see clearly that x, which is 7, and y, which is x, which is 10, and y, which is 7, we added together, and the result is 17. So that's because these two conditions were met. So let's see what happens if one of those conditions is false. So x being 10 and then y being 7. So let's perform the same operation, but this time around, the conditions now will tweak it, just tweak it a little bit. So in this case now, you see that x, okay, x is still greater than 0 because x is 10, and then y now is not greater than the value we indicated here. Also y is 7, so 7 greater than 10 is false. And we are using this AND operator. So what do you think would happen? Okay, it's simple. Since one of the condition is false, so the whole parenthesis, everything here, all the conditions now will evaluate to false, even though there is true, even though there is false. But since there is just one false, everything evaluates to 0 into false. So when we run this particular line of code, we'll see that our else statement gets executed. So the take home is that when you're using the AND condition operator, all the conditions does not necessarily have to be only 2 conditions. There can be more, there can be hundreds, there can be more conditions, depending on how you want. So the AND operator there ensures that at least all the conditions are true before the true part the instruction for true will execute. Else, the else condition, the else instruction will just execute. So that's that. Okay, so now going to the OR operator. So in this particular case now, I want to check if x is greater than 9 or y is greater than 5. So remember that our x is 10 and our y is 7. So whenever we are using the OR operator, at least one of the conditions must be true before the whole parentheses, the whole code in the whole conditions will execute to true. At least one should be true. So in this particular case now, x being 10 is greater than 7. That's true. It's greater than 9. That's true. And then y being 7 is greater than 5 as well. So this particular case, the two conditions are true. So this particular conditions, all of it will evaluate to true. And then let's run the code. So 17 is still the answer. We're adding x and y, 10 and 7. But in this case, that unlike the AND operator, that the two conditions had to be true. So in this case now, we want to see if x is greater than 20. Remember, x is 10, and then y is 7. So what do you think will happen if x will now say x greater than 20, where x is 10? So let's run that particular thing. You see that this evaluates to false. So it means that this condition is false. So let's check the other one. y greater than 0, y is 7, so 7 should be greater than 0, and this is true. So combining these two operators, these two conditions now with the or operator, so we see that it still evaluates to true because at least one of the condition is true. So let's run this particular line. So we see that our output is 70 because one of the condition is met. So the else is not executed. This particular part is executed. So I hope that is clear. So going further, so note that the curly braces must be used if the instructions of an if statement span across multiple lines. So this is what I was talking about earlier. So, initially, all what we've been doing, our code does not span more than one line. So let's see a situation where we have a more than, like we have a complex, let me put it that way, instruction to run, or we want to assign variables, or want to just do something that will span more than one line. So in this case, x, assigning the value 10 to x. So we want to check if x is greater than or equal to 0. And then notice the curly braces here. So this just means that, okay, we want to ensure that whatever comes after this is still within it. So wherever the curly braces get closed, whatever is inside that particular braces gets taken as the instruction. So that's just what this particular place is. So if x is greater than or equal to 0, then x, assigning x to a sequence of 0 to x, and then we want the length to be 10. Remember, in our last class, we discussed creating vector with some functions, some base R functions. So sequence, we discussed sequence. So sequence is a function that helps us to create a sequence depending on the start and the end values that we provide or that we indicate. So in this case now, we want our sequence to start from 0 and we want it to end at 10, and then we want the length to be 10. So let's particular run only this. Let me show you what the output looks like. So this is what the outputs look like. So this is what this is the vector now. Okay, so we want to assign this value, like we want to create a variable and assign this vector to it, and then we want to check the sum and then square it. We want to check the sum and then square it, and then for this particular true part, this is what we execute if the condition is true. You see how this curly braces here ends this particular block of instruction. So this is a partition. They're just partitioning it and making sure that everything inside this and within this braces is seen as single instruction. So else, and the other part of it, we started it with another curly braces, and then it ends with the curly braces. So this is another block of instructions. So that's just what it is. So let me run this particular line of code. So we see that the output is 2500 because x is greater than or equal to 0. So what it means is that only this particular partition or this block got executed because the condition is met. The else part was not executed. So the curly braces make sure that we're able to write our code more than one line. You see that this is one line, this is another line, 62, and then we'll ended the block at 64. So that's just what the curly braces helps us to achieve. So let's see an instance where x is less than 0. So what I'll do, I'll just change this particular initial value, this value here to negative, so that x will be less than 0. So you know that this condition here, we want to check if x is greater than or equal to 0. So now that x is less than 10, now that x is minus 10, so let's see what happens when we run the code. So okay, so you see that else stop is the result. So what this means is that this particular part did not execute because the condition was false, and then the else part was executed. So this part was executed, this else, then the sum of x. So the sum function is just as you would assume, it sums vectors together. So we're saying sum of this vector that we created, this vector, sum of this vector, and we are taking their square. We are taking their square. Like, okay, this part gets executed first, and then the sum. Okay, so going further, we can also nest if statements. Like in this example now, if we are dealing with situations where we would want the conditions to be more than just a simple, like more than just one, let me put it that way. So we can also nest if statements. We can use an if statement inside another if statement. So let me assign the value 90 to x and then run this particular line, this particular chunk. Okay, so, oh, sorry. Sorry for that. I think I forgot some part of the code. So let me run this line. So see this particular condition now. X is 90. We want to check if x is less than or equal to 0. So if x is less than or equal to 0, okay, the first instructions that we provided, like the first instruction should run, you know, right? So the first one should run, that is whenever our condition is true. So instead of that particular instruction, we're using another if statement to check if x is also less than or equal to 50. So this condition gets checked, and then inside of it, another condition gets checked. So if these two conditions are met, we want this to be our output. Your number is lower than or equal to 50. So see how these curly braces separate this first one, this first, like the main condition, to the nested one. So from here, from this part to this part, is actually the block of instruction for the nested if statement. So else this block. So if this particular number is not less than or equal to 50, so this particular block will run. That is, your number is between 50 and 100. So if both conditions now are not met, if this condition is false and this condition is false, what will happen? We just want this particular block to run. So your number is greater than 50. I hope this is not confusing, Sha. I hope you can see how different the codes are, how they separate each other with the curly braces, how they are different from each other. So this particular curly braces take care of like this block, and then this one takes care of the other block. Let me see. Okay, this one takes care of this block. You see how whenever I put my cursor close to any particular curly braces, it gives me the position, like the open or the position of the start curly braces. If I put here, you see that somehow this particular part is highlighted. So that's just that. So now it helps us to know where this the start and end point of a particular block of code. So this particular example now, our x value being 90 is less than or equal to 100, but it is greater than 50. So this particular chunk will not be executed, but this chunk will be executed, because here the condition is that this our x value is not less than or equal to 50. So the else part of this condition now gets executed. So I hope that's clear. So let's see what happens when we change. Okay, look at the output. Your number is between 50 and 100. So let's see what will happen if our value is greater than 100. So let me run this line. So you see that our number is greater than 100. So that's just that for the that part of nesting. So we'll take a quick break now, and then in 15 minutes time, we'll come back to continue the class. So I'll share the link for you to join the next section of the class. So thank you very much.